Good morning, students. So let's start with the revision of the last previous classes video. We were discussing about the units, the choice of the units and the traditional unit systems, and the units which were used, or the common unit systems which were used by the medieval period. Okay, so unit is defined as the standard. Okay, so unit of a physical quantity is a well-defined standard in terms of which similar quantities can be measured. Okay, suppose if I'm using a scale, see, everybody has a scale. So a scale, you can see the markings are given in terms of millimeters. So we can use this defined quantities to measure the length of any undefined quantity like this line. Okay, so we'll do that. So this millimeter which is written in the scale is a unit. Okay, then we have also discussed about the choice of the unit, that the standard unit should have some properties, and in the medieval time the units which were used, the common units which were used like CGS, FPS and MKS, they vary. Okay, like FPS varied in different countries, so there was a need to standardize the unit system. So this unit system was known as SI unit system. Okay, this was used to avoid the confusion. Okay, we have also discussed about the types of unit. See, fundamental units and derived units. We have discussed about the two quantities, the fundamental quantities and the derived physical quantities. So fundamental quantities are the basic quantities, so their units also will be fundamental units or the basic units. Suppose for fundamental quantity we use the unit meter or centimeter. Okay, so derived units are used for the derived quantities like area. Suppose we are taking out the area of a rectangle, then we derive it with the multiplying the length and the breadth together, so the units will also be multiplied. So this is the unit for this derived quantity area, meter square. So this unit, the meter square, will be known as derived unit. I hope you don't have any confusion. Now let's discuss once again the CGS system, that is C stands for centimeter, okay, G for gram and S for second, F stands for foot, P for pound, S for second, and M stands for meter, kilogram and second. So these are the three common unit systems. Now today we'll discuss the SI system. See, to avoid the confusion and the inconvenience, so in 1960, in the year 1960, by the General Conference of Weights and Measures, a unit system known as SI unit system. SI stands for Systeme Internationale. Okay, the unites in French, it means international system of units. Okay, so this is the full form of SI. So a unit system was developed and it was accepted internationally. That means the value won't change from place to place. It had 7 fundamental or basic units. How many? 7 fundamental or basic units in all. So let's see what were the fundamental quantities and what are their SI units. So the fundamental quantities are written here in this column, and the abbreviations and the SI units are written in this column. So for length, the standard unit is meter, mass kilogram, time second, temperature Kelvin, electric current ampere, amount of substance mole, and luminous intensity candela. Okay, M K S K A M C D. Okay, so you can learn with the formula M K S K A M C D. Or my cousin second Kevin asked more Cadbury. Okay, so this is the formula for remembering the the SI units for fundamental quantities. So what is that? My cousin, it won't start with C. Okay, so for my cousin second Kevin asked more Cadbury. Okay, cousin. So C, you won't write C for cousin, K you will write. So then it is easier for you. So M stands for meter, K for kg, S for second, then K for Kevin. Second and Kevin are written here. A for ampere, M for MO for mole, and C for candela. Okay, so this is the formula for remembering. Okay, I hope it will be easier for you to remember this way. Now we'll see how to write the units in the standardized or SI system. There are certain rules how to write it correctly. Now you can ask me one more question, ma'am. You have written the units for the base quantities or the fundamental quantities, but why I haven't written for the units of the derived quantities? Yes, you are right. The unit of the derived quantities can be found out by knowing the formula of the derived quantities. Suppose we have to find out the units of the area. Then we'll see the units of the length, meter, and the breadth unit also will be same, meter. So we'll multiply meter, and we'll get the unit for the area. Yes, no? If area of a square will be side into side, so for measuring the side we'll use the unit of the length, that is meter and meter. So we can get meter square. For volume again. So we can, if we have the knowledge of these basic units, then we can find the derived units too. Okay. In SI system, the multiples and the sum multiples of the units are formed. As in the metric system you have learnt in standard 5. So let's discuss once more. So this is the metric system we have discussed in standard 5. Do you remember King Henry doesn't usually drink chocolate milk? So K stands for kilo, H stands for, see this K stands for kilo, H stands for hecto, D stands for deca, U stands for unit, that is meter, where liter, gram, where D small d stands for deci, C stands for centi, and M for milli. Okay, so the metric system we have discussed according to the length: kilo, hecto, deca, meter, deci, centi, milli, meter. So this was the metric system we have discussed. Okay, now we'll see the multiples of the units and the sum multiples of the units. But before that, we should read about the rules for the standard unit system. See how to write standard unit system. First rule is the name of the unit is always written in the small letters, including the case when it is named after a scientist. Multiple means larger form. So to create larger forms, we use multiples, and to create smaller forms, we do some multiples for creating smaller forms. So to create smaller forms, we use some multiples. Okay, we use some multiples, and to create larger forms, we use multiples. This is the ladder system, if you will see. So from smaller to bigger, you need to divide, and from bigger to smaller, you need to multiply with 10. So this is the general formula for writing. Suppose, see, 1 kilo, if you will convert it to the smaller form hecto. So 10 hectometer is 1 kilometer. So when you will convert from hectometer to kilometer, you will divide with 10, and when you will convert kilometer to hectometer, you will multiply with 10. Okay, so this is the ladder formula for reading. Now see table number 2.2 of your book. See here, the prefix and the symbol and the values are given: peta, tera, giga, mega, kilo, hecto, deca, and the symbol is PTG, M, small k, h, da. See here. So the formula for remembering this one, or the value, is, okay, so 10 you will write everywhere. So 10 to the power 2, 10 to the power 3, 10 to the power 6, 10 to the power 9, and 10 to the power 12. So this is the formula: PTG, MK, HDA, 15, 12, 9, 6, 3, 2, 1. Okay, so P15, T 10 to the power 12, G 10 to the power 9, M 10 to the power 6, K 10 to the power 3, H 10 to the power 2, and DA 10. This is the value. Okay, so this is the formula. So P 10 to the power 15, T 10 to the power 12, G 10 to the power 9, M 10 to the power 6, K 10 to the power 3, H 10 to the power 2, and 10. So this is the value. Now the rules for SI unit. If you will see in your book, certain rules are given. So when you will write the SI unit, you have to keep in mind certain rules, like the name of a unit is always written in small letters. Okay, suppose kg, so k is small, g is small. G for gram, so that is the name of the unit. When we are writing joule, joule is the unit named after any scientist, then also we will use small symbols. Okay, but the symbols of units named after the scientist, like Newton and Watt, are always written in capital letters. Okay, the symbols of the derived unit, when they are formed by multiplication, are joined with a space or a center dot, like Newton second, like this. Okay, S is small, so capital N, S, and dot, like this you will write. Okay, or meter per second minus 1, so S is small. The names of the unit can be written in plural form, but symbols are never written in plural form. They are always written in singular form. So if you are writing 5 meters, so this you can write in plural form, but when you will use the symbol, you will write 5m. Okay, so this will be always in singular form. Okay, symbols are not abbreviations, so there would be no full stop. You cannot put full stop in the end. So these are the certain rules for SI units. Now for today's class work, you will do page number 16, stop and reflect. Okay, so this will be, you will do as class work, and here you can find the submultiples. So here also the submultiples are there: deci, centi, milli, micro, nano, pico, femto. So the symbols are given here, and the formulas are also given. So -1, -2, -3, -6, -9, -12, -15. That it gets reversed. Okay. So here the formula for remembering the sum multiples is deci, centi, milli, micro, nano, pico and femto. So the symbols will write D, C, M, mu, N, P, F. Okay, we are not writing this. So there will be -1, -2, -3, -6, -9, -12, -15. That will be reversed. So you'll write 10 to the power, you'll just add. Okay, so this is the formula. So this all for today. Tomorrow we'll see measuring length and the instruments, and then measuring weights.